In dynamic simulation, we need for this pinion gear to roll around this elliptical gear, and so to do that we can do that with a rolling cylinder on curve. So think of the elliptical gear as the cylinder, and then the elliptical gear as the curve, and then the follower or the pinion gear as the cylinder. So even though it shows an image like this, break it down to its most basic geometry. So we have a cylinder, we have a curve. And so I put that in then as a rolling cylinder on curve joint. I have a revolution joint here for the shaft, and a revolution joint up here for the pinion gear, and then a prismatic gear for the pinion gear to move up and down within this holder. And so I'll go ahead and play that motion. Now the real trick, well, there's two real tricks, is one, to get the correct pitch, the pitch curves for the pinion gear and for the elliptical gear, such that the teeth don't interfere with each other as it's rotating around. And so here we see, if we do get that correct, here we see the motion of the pinion going around the elliptical gear. Let's speed that up a little bit. If we want to continuously run that in a loop, if we want to reverse the direction, I will go to the revolution joint, I'll go to the properties, and I'm going to simply reverse that direction with a minus sign. The other way we could have done it is I could edit that revolution joint and flip the z-axis, and that would change the direction. Anything that we want to know about that, for example, the acceleration, say, of the prismatic joint. And so if I want to know the acceleration curve for that prismatic joint, if I want to know velocity, various parameters, if I want to know on the revolution, the acceleration curve for that is just a constant acceleration. And so yeah, that's Inventor dynamic simulation.